The limit of a function f of x is the value it approaches as the value of x approaches a certain value. When working with tables, the best we can do is to estimate the limit value. Limits can also be illustrated graphically. The limit of f of x as x approaches c is not always equal to f of c. The real-life limits are used anytime a real-world application approaches a steady solution. Good day! Today we will discuss limits and how real-life situations are applied with these limits. At the end of this video, you are able to define limits, illustrate the limit of a function using table of values and the graph of the function, distinguish between the limit of f of x as x approaches c, and f of x. The limit of a function f of x is the value it approaches as the value of x approaches a certain value. The limit of f of x as x approaches c or a certain value is equal to L. When working with tables, the best we can do is to estimate the limit value. Here's an example to understand it further. Use table to estimate the limit of x squared plus x minus 12 all over x minus 3 as x approaches 3. And if we do table of values to find the limit, what x values are approaching 3 from the left side, well, we can use 2, 2.5, 2.9, 2.99, 2.999, and so on and so forth just to get closer to 3. So if we plug into our x values for this function, we will get 6. If we plug in 2.5, we'll get 6.5. If we plug in 2.9, we'll get 6.9. If we plug in 2.99, we'll get 6.99. If we plug in 2.999, we'll get 6.999. So it's pretty obvious that as x is approaching 3 from the left side, f of x is approaching 7. Now let's do it from the right side. So let's use 4, 3.5, 3.1, 3.01, 3.001, and so on and so forth just to get closer to 3. If we plug in 4 into our x values, we will get 8. If we plug in 3.5, we'll get 7.5. If we plug in 3.1, we'll get 7.1. If we plug in 3.01, we'll get 7.01. If we plug in 3.001, we'll get 7.001. So we could see from this table that as x approaches 3 from the right side, f of x is approaching 7. Since the limit of x squared plus x minus 12 all over x minus 3 as x approaches 3, both from left and right side is equal to 7, we can say that the limit of x squared plus x minus 12 all over x minus 3 as x approaches 3 is equal to 7. In some cases, function seems to approach to different values. Therefore, that limit does not exist or an example of a one-sided limit. So let's take a look first at this graph and evaluate a limit. So we have here the value of f of x, the left hand, the right hand, and the general limit. To really kind of understand that, we have to evaluate the function. So by looking at the graph, we can say that the f of 3 is equal to 1. Though there is a point at 3 here in y coordinate, it could not be the value of f of 3 since it is unshaded, indicating that it is undefined. So that's evaluating a function, and that is not talking about the limits. The limit says, what is the value that you are approaching as you are getting really close to a certain value. The limit means from your left or right hand. As x gets really close to 3, what f of x value are you approaching? So from my left hand, as I get really close to 3, the value I am approaching is 3. What about from my right hand? I get really close to 3. What about from the both my left and my right hand? I am approaching 3. The real-life applications of a limits. The real-life limits are used anytime a real-world application approaches a steady solution. Let's have the stock market as an example. Let's say you are supposed to buy stocks of Robinson's Land Corporation with a cost of 17.60 pesos per stock, but you only have 1,760 pesos for your start. In symbol, the limit of x over 17.60 as x approaches 1,760. First, we need to evaluate the function. The function is x over 17.60. So if we substitute 1,760 in x, we will have f of 1,760 is equal to 100. If we are to do a table of values for this function, we can use 1,720, 1,730, 1,740, 1,750, 1,755, and 1,759 as values of x as we approach to 1,760 from the left. We just need to substitute all the values of x to the given function. So if we plug in 1,720, we'll get 97.72. If we plug in 1,730, we'll get 98.30. If we plug in 1,740, we'll get 98.86. If we plug in 1,750, we'll get 99.43. If we plug in 1,755, we'll get 99.72. If we plug in 1,759, we'll get 99.94. So as x approaches 1,760 from the left, we approach the value of 100. Thus, the limit of x over 17.60 as x approaches 1,760 from the left is equal to 100. To show it with graph, let the amount of money be on our x-axis. So we have 1,720, 1,730, 1,740, 1,750, and 1,760. Then on our y-axis, which is the output, it is the number of RLC stocks that can be brought with a certain amount. So we have 97, 98, 99, and 100. Next, we need to plot the coordinates. So in our input 1,720, we have an output of 97.72. So it's supposed to be here between 97 and 98. In 1,730, we have 98.30 that is in here between 98 and 99. In 1,740, we have 98.86, also here between 98 and 99 but closer to 99. In 1,750, we have 99.43 which is here quite in the middle of 99 and 100. In 1,755, we have 99.72 between 99 and 100 that is closer to 100. And lastly, in 1,759, we have 99.94 that is much closer to 100 compared to previous one. Then connecting the dots, we'll have a positive line graph. Since we are talking about money and stocks here, there will be no negative involved for there is no negative amount and negative stocks. So we can see that as the amount of money increases, the number of stocks that can be bought also increases. And if you only have 1,760 pesos, the number of stocks you can buy is limited to 100 stocks. And that's all. I hope you learned something from our discussion. Have a nice day!